angle modulation there are two topics, you know that. Now FM modulation which we are finished. Now in angle modulation, now we'll see the phase modulation, okay, PM. You know why phase modulation and frequency modulation is called as angle modulation? Why these two are called as angle modulation? Because when angle is changing, when frequency is changing, angle changes, or when phase is changes, angle is changes. You know that, right? Now, okay, phase modulation. What is the phase modulation definition? First you tell me. Now, the phase of the carrier is changed in accordance with the instantaneous phase of the carrier is changed in accordance with the amplitude of the message signal. Okay, everywhere the amplitude of the message signal is changing, everywhere the phase is changing. Okay, phase of the carrier before modulation and after modulation is not same. Amplitude and frequency before and after is same, but phase of the carrier before modulation and phase of the carrier after amplitude modulation will not same. Okay, because this is the phase modulation and any change is depends upon the amplitude of the message signal. Therefore, now you see here, this is carrier before modulation, AC cos 2 pi FCT plus phi. Now this is carrier before modulation, right? Now what is the carrier after phase modulation? There is no change in amplitude, there is no change in frequency, and there is a change in phase. Am I not? Now that phase change is completely depends upon amplitude of the message signal. That phase change is completely depends upon amplitude of the message signal. Now see here, this is carrier before modulation, this is carrier before modulation, and this is carrier after phase modulation. This is carrier after phase modulation. This is PM wave in time domain. Am I not? Now this is a phi. So can I write like this? S of t of Tm, which is equal to AC cos 2 pi FCT plus Kp into m of t. What is m of t? Now, or you can take it in another way. This is angle before modulation, but this is the instantaneous angle after phase modulation, that we can take separately. The instantaneous angle after phase modulation, because now the angle, the phase is changes, angle is changes. That's why the phase modulation is called as angle modulation. Frequency changes, angle is changes. Therefore, frequency modulation is called as angle modulation. And instantaneous angle after phase modulation, theta I, which is equal to 2 pi FCT plus Kp into m of t. Now this is theta I. Now this theta I, which is nothing but units are radians. Now this is omega, 2 pi f is omega, omega into t, you know that. Now what is angular frequency? Angular frequency is d theta by dt radians per second. Now which is theta, which is equal to omega into t, d theta by dt. Now theta equal to omega into t, or theta equal to 2 pi f into t. Now this is radians per second into second, second cancel, therefore which is nothing but radians. So now this is radians, therefore this is also radians. But now this is voltage variation, signal variation is voltage variation. Therefore what is the units of Kp? Now this is Kp, which is nothing but radians per volt or degree per volt. Generally we are taking radians. Therefore what is Kp? Kp is a sensitivity of the phase modulator. Kp, which is sensitivity of phase modulator. Ka is a sensitivity of amplitude modulator. Kf is a sensitivity of frequency modulator. Kp is a sensitivity of phase modulator. Now this is Kp. Now m of t, what is m of t? You know that m of t is am cos 2 pi fm into t. Therefore, now this is the instantaneous angle after FM modulation. Now see here, S of t of Pm phase modulated signal AC cos 2 pi fct plus Kp into Am. Okay, now this is Kp into Am. Now let us see here. This is before modulation. Assume this is radians. Okay, 0 radians. Before modulation phase is, let us assume, before modulation carrier phase is 0 radians. Therefore, after modulation, now again 0 radians, but this 0 radians is going to be changed. This 0 radians is going to be changed Kp into m of t. What is m of t? M of t is Am cos 2 pi fm into t. Is it right or not? Now this is after modulation. Now let us change. Before modulation is 0 radians. Before modulation phase is 0 radians. Now after modulation, what is the maximum phase? The maximum phase after modulation is 0 radians plus Kp into Am. The maximum value of cos is 1. This is after modulation. And the minimum phase after modulation is 0 radians minus the minimum value of cos is 1. Therefore, Kp into Am. This is minus 1 and then minus here. Okay. Now this is before modulation and this is after phase modulation. Now you tell me, before modulation 0 radians, after modulation also 0 radians, but that 0 radians is deviated. Before modulation 0 radians, after modulation 0 radians, but that phase is deviated. Now phase is deviated by an amount of, how much is deviated? The phase is deviated by an amount of Kp into Am. Now this is called as phase deviation. This is called as phase deviation delta phi, which is equal to Kp into Am. Units are radians, because this is radians per volt, volt cancel radians. Okay, this is the phase deviation. So can I write like here, what is Kp into Am? Phase deviation delta phi into cos 2 pi fm into t. Okay, note on this. In phase modulation, now this is the Pm wave, which is equal to AC cos 2 pi fct plus beta into cos 2 pi fm into t. Now see here, in Pm, in phase modulation, whatever the phase deviation, that itself is called as modulation index. In Pm, whatever the phase deviation, and modulation index both are same. In Pm, the phase deviation and modulation index both are same. This is the Pm wave in time domain, Pm signal in time domain. Okay, note on this. Therefore, now you see here, S of t of Fm, which is equal to AC cos 2 pi FCT plus beta sine 2 pi Fm into t. This is the Fm signal. Okay. Now, what is PM signal? S of t of PM, which is equal to AC cos 2 pi FCT plus beta into cos 2 pi Fm into t. See here, both are appears to be same or not? Yes, both are appears to be same. This is PM signal, this is FM signal, AC, FC, modulation index, 2 pi FM, everything is appears to be same. Now, because now PM and FM both are similar, appears to be same. The magnitude spectrum of AM and FM both are same. See here, can I write like this? Which is nothing but AC into cos of theta. Can I write like this? Because that is the instantaneous angle. What about here? This is also AC into cos of theta. This is a theta. Am I not? Now, see here, this is AC cos of theta. What is the magnitude spectrum? The magnitude spectrum of FM and PM both are appears to be same. AC square by 2R, amplitude is same. Amplitude before modulation, after frequency modulation and after phase modulation will not affected. Therefore, now see here, first point, the magnitude spectrum of FM and PM both are same. So the power will be same, bandwidth will be same. Is it right or not? Now see the equations also. The time domain equation of FM signal is same as the time domain equation of FM signal is same as of PM signal. The time domain equation of PM, we are talking about PM, no? PM signal is same as of FM signal. Same, PM signal will be same as FM signal, except there is a phase shift of 90 degrees at message frequency. Both are appears to be same, but there is a phase shift of 90 degrees at message signal in PM. Okay. Therefore, magnitude spectrum is same, both are same. Therefore, the total power and bandwidth of PM is same as that of FM. Therefore, now what is the total power? The total power required to transmit a PM signal is AC square by 2R, which is the unmodulated carrier power, and bandwidth which is equal to 2 into beta plus 1 into Fm, where here beta is a phase deviation which is equal to Kp into Am. Okay, note down. Signal S of t, consider an angle modulated signal S of t. He is not mentioned FM modulation, he is not mentioned PM modulation, he is mentioned angle modulated signal. So you can treat it, what are the parameter he is asking, based on that you treated this signal as FM or you treated this signal as PM. So S of t, which is equal to 10 cos 2 pi into 10 power 6 into t plus 10 cos 2 pi into 10 power 6 into t plus 5 sin 8 pi into 10 power 3 into t. Now this is an FM signal. Now this is an angle modulated signal represented in time domain. Now what he is asking is determine frequency deviation and phase deviation. Very simple question. S of t, which is equal to AC cos 2 pi fct plus beta sin 2 pi fm into t. So what he is asking is, he is asking frequency deviation and he is asking phase deviation. While you are answering a question of phase deviation, treated this as PM. While you are answering the question of frequency deviation, treated this as FM. So phase deviation, I am assuming this is PM signal. Phase deviation beta, which is equal to phi. But in phase modulation, phase deviation and modulation index both are same, delta phi. Therefore, delta phi, which is equal to phi radians, phase deviation. Now frequency deviation. Now the frequency deviation, I want to find delta f. Delta f, which is equal to beta equal to delta f by fm. Delta f equal to beta into fm. Now the frequency deviation, which is equal to modulation index beta, is phi into fm, frequency of the message signal. What is the frequency of the message signal? 4 kHz. Therefore, the frequency deviation, which is equal to 20 kHz. This is the question number 1. Consider an angle modulated signal. Now question number 2. Consider an angle modulated signal. Ten cos 2 pi into 10 power 6 into t plus 8 sin 2 pi into 10 power 3 into t. Determine modulation index, frequency deviation, bandwidth and power. Determine modulation index, frequency deviation, bandwidth and power. A frequency deviation, which is nothing but, and treated this signal as FM signal. Let us assume this signal as an FM signal, and first you find the parameters. What are the parameters? Now if you compare, modulation index is 8 and AC is 10 volts and FM is 4 kHz. FM equal to 2 pi, so FM, which is equal to 4 kHz. Eight sin 2 pi, this is 2 pi. 8 sin 2 pi means FM is now only 1 kHz. So now what he is asking? He is asking modulation index, frequency deviation, bandwidth and power. Okay. So now we'll treat this as an FM signal. Now modulation index is over 8 wideband FM, because which is greater than 1, and frequency deviation delta f, which is equal to beta into FM, which is 8 into 1 kilo, which is equal to 8 kilohertz, and bandwidth, which is equal to 2 into beta plus 1 into FM, 8 plus 1, 9 into 2, 18 kilohertz, and the total power, which is equal to AC square by 2R, which is equal to 50 watts. Note down. Now in the same question itself, he is asking, repeat all the above calculations when the message signal frequency is doubled. Repeat all the above calculations when the message signal frequency is doubled. Repeat all the above calculations when the message signal frequency is doubled. Repeat all these above calculations when the message signal frequency is doubled. FM nu, which is equal to 2 FM, which is equal to 2 kilohertz. Now the modulation index beta. What is the modulation index beta? The modulation index beta, which is equal to delta F, which is equal to KF into AM. So message signal frequency is changed, frequency deviation will not affected. So same 8 kilohertz. And modulation index beta, which is equal to delta F into FM. So now FM is affected. So delta F is 8 kilo into FM is doubled 2. Therefore, which is equal to modulation index beta, which is equal to delta F by FM. Now this is delta beta nu FM nu, which is equal to delta F by FM nu is 2 FM, which is equal to beta old by 2, which is nothing but reduced. When message signal frequency is double, modulation index is reduced by a factor of 2. Modulation index is half. Now bandwidth. Now the bandwidth, which is equal to 2 into beta plus 1 into FM. Beta is changed. 4 plus 1 into FM is changed, which is equal to 2 kilo, which is equal to 5 into 2, 10 into 2, 20 kilohertz. Now the total power which is equal to AC square by 2R, which is equal to 50 watts. Now this is all calculations when the message signal frequency is doubled. Now he is asking, now I am treated this as FM signal, right? I am treated this as FM and we will do all these things. Now you treated the same signal as PM and calculate all these things. The same signal as PM. Now first you note down this and we'll repeat the question. Question here, you just concentrate. For comparison also you can do. Now the modulation index is 8, AC is 10 volts, frequency of the message signal is 1 kHz. Now treated this as PM, so the modulation index is 8. Now in PM the phase deviation, modulation index both are same, which is equal to 8 radians. Now bandwidth, which is equal to 2 into beta plus 1 into FM, which is equal to 9 into 2, 18 kilohertz, and the total power, which is equal to AC square by 2R, which is equal to 50 watts. Treated this as PM signal. Now repeat all the above calculations when the message signal frequency is doubled. When the message signal frequency is doubled, FM nu, which is equal to 2 FM, which is equal to 2 into 1, 2 kilohertz. Now modulation index beta, the modulation index beta, which is equal to Kp into AM. So it is independent of the message signal frequency, so it remains same. And the phase deviation, modulation index both are same, which is equal to 8 radians, because modulation index and phase deviation, modulation index and phase deviation does not affect it, it is independent of the message signal frequency. And bandwidth which is equal to 2 into beta plus 1 into FM nu, which is equal to 2 into 8 plus 1 into FM nu is 2 kilo, 9 into 2, 18 into 2, which is equal to 36 kilohertz, and the total power, which is equal to AC square by 2R, which is equal to 50 watts. Then what you can understand with this problem, when the message signal frequency is doubled, see here, when the message signal frequency is doubled, bandwidth is not changed in FM, bandwidth is not doubled in FM, okay, only the modulation index is reduced by half. But here in PM, the message signal frequency is doubled, the bandwidth is doubled. When the message signal frequency is doubled, bandwidth is doubled in PM, and bandwidth is not doubled in FM, because a bandwidth is not only message signal frequency but also modulation index beta. Because this is doubled and modulation index is reduced by half, that's why this is not changed, not doubled. And at the same time, if you see here, now bandwidth of AM 1 is 2 FM, but now bandwidth of AM 2 is message signal frequency is doubled, so FM nu, which is equal to now 2 into, now it is doubled 2 times. So what is FM nu? is 2 times of FM. Now what happen, you see. So now the bandwidth of AM2, which is equal to now 2 into, now can I write like this is bandwidth of AM1, this is bandwidth of AM1. So when the message signal frequency is doubled, listen, very very important points here. When the message signal frequency is doubled, bandwidth of AM as well as bandwidth of PM are doubled, but bandwidth of FM is not doubled. Okay, bandwidth of AM and bandwidth of PM are doubled when the message signal frequency is doubled, but bandwidth of PM are not doubled. When this is M1 of t, so S1 of t is M1 of t into cos 2 pi FCT, DSB-SC signal. Now first I am checking with DSB-SC signal. Now all these analog modulation techniques, linearities we are verifying. Linearity of angle modulation or of total. Linearity of analog modulation techniques. Linearity of analog modulation techniques. All will find AM, FM, PM, DSB-SC, SSB-SC, VSB-SC. We will find the linearities of all these things. Okay. Now first we will start with a DSB-SC for easy understanding. Now what is M2 of t? Which is nothing but S2 of t, which is equal to M2 of t into cos 2 pi FCT. Now when linearity property, homogeneity and superposition theorem, M1 of t plus M2 of t as a input, as a signal. Therefore what is S of t? S of t, which is equal to M1 of t plus M2 of t into cos 2 pi FCT. Why? Because what is a DSB-SC signal? What is actual DSB-SC signal? The actual DSB-SC signal is S of t, which is equal to M of t into cos 2 pi FCT. Therefore S of t, which is equal to M1 of t into cos 2 pi FCT plus M2 of t into cos 2 pi FCT. Therefore now this is S of t, which is equal to S1 of t plus S2 of t. Yes, S of t is equal to S1 of t plus S2 of t. Then this is holds good the homogeneity principle. Therefore this DSB-SC signal is a linear modulation. Okay, this DSB-SC signal is a linear modulation. Note down. This is input M of t. Now this is the DSB-SC modulator. Output, which is equal to S of t, which is equal to M of t into cos 2 pi FCT. Okay. And therefore this is the linear property. Now I'll check with FM. Clear or not? Now we'll verify with FM. Now this is FM signal. Now we'll see the FM modulator. FM modulator. This is input m of t. What is output? Output which is equal to s of t, which is equal to AC cos 2 pi fct plus 2 pi kf integral m of t dt. Now this is the output of FM signal. This is FM. Now we'll check the linearity of FM. So for M1 of t, now this is S1 of t, which is nothing but AC cos 2 pi fct plus 2 pi kf integral m1 of t dt. Now for M2 of t, which is nothing but AC cos 2 pi fct plus 2 pi kf integral m2 of t dt. Now m1 of t and m2 of t as input. Therefore now this is AC cos 2 pi fct plus 2 pi kf integral m of t is now m1 of t plus m2 of t into dt. So now definitely this is s of t AC cos of 2 pi fct plus 2 pi kf integral m1 of t dt plus 2 pi kf integral m2 of t dt. But what we want? Now this is s of t, which is now you cannot write this is not a s1 and this is not a s of t is not equal to s1 of t plus s2 of t. S of t is not equal to s1 of t plus s2 of t. Therefore now this FM is not a linear modulation, then this is a non-linear modulation. Understand now? Now this FM is a non-linear modulation, right? Now similar, first you note down this. Now obviously PM is also same, so this PM is also not a linear modulation. Okay, this is a non-linear modulation. Now if it is PM modulator, because PM is also same, no? PM modulator, AC cos 2 pi fct plus Kp into m of t. This is PM signal. PM. Okay, PM modulator. Therefore, AC cos 2 pi fct plus Kp into m of t, m1 of t. Now this is plus Kp into m2 of t. Now m1 of t plus m2 of t, now which is nothing but this is Kp into m of t is nothing but m1 of t plus m2 of t. Now this is nothing but Kp m1 of t plus Kp m2 of t. Now therefore this is s of t, which is not equal to s1 of t plus s2 of t. Therefore PM is also not a linear modulator, PM is also a non-linear modulator. Now AM. Now what is AM modulator? AC, S of t, S of t, which is equal to AC cos 2 pi FCT plus AC S of t, which is equal to AC cos 2 pi FCT plus KA AC into 1 plus KA M of t into cos 2 pi FCT. Therefore, AC cos 2 pi FCT plus AC KA M of t into cos 2 pi FCT is AM signal. Therefore, S1 of t, which is equal to AC into 1 plus KA into M1 of t into cos 2 pi FCT. Now S2 of t is AC into 1 plus KA into M2 of t into cos 2 pi FCT. M1 of t plus M2 of t, which is equal to AC into 1 plus KA into M1 of t plus M2 of t into cos 2 pi FCT. Now S of t, which is equal to AC cos 2 pi FCT plus AC KA M1 of t into cos 2 pi FCT plus AC KA M2 of t into cos 2 pi FCT. Now this is S of t, which is equal to S of t, which is not equal to S1 of t plus S2 of t. So AM is also a non-linear modulation. Therefore, now the DSBSC, its derivatives. What is the DSBSC? Its derivative. Now DSBSC, SSBSC and VSBSC. Now all these are the linear modulation techniques, and these three are non-linear modulation techniques. What we conclude finally? AM, FM, PM are non-linear modulation techniques. Non-linear modulation. Now whereas DSBSC, SSBSC, VSBSC, all these are linear modulation techniques. Clear or not? Now this is the non-linear modulation techniques. This is the linear modulation. Note down.